so on the front side, we're given the function, and we have to sketch a graph of the derivative, which we have done before. So this is kind of more practice, given a little more, tricky graph. So here's our function. We need to sketch a graph of the derivative. So I'm going to set up the same sort of scale. On my x-axis. Tell me one point on that function, if you can, where you know the slope. 0. Okay, so at 0, the slope is 0. So at 0 over here, I'm going to plot a point having a slope of, at the value of 0. Where else? I think it looks like positive and negative 1. But the point is, at positive 1, the slope is 0. So at positive 1 over here, I'm also going to have a slope of 0. Now, what is the slope in between 0 and 1? Is it positive or negative? It's negative. So when I connect these 2 points, I need to just make sure I dip into the negatives, meaning below the x-axis. Okay? And I also have a slope of 0 at negative 1. What is happening? What is the slope between 0 and negative 1? Positive. So when I connect those, I need to make sure I dip into the positives a little bit. Okay? Prior to negative 1, what's the slope? Negative. And increase, as you get further and further away, the more negative it is, right? The steeper that is. So this is just going to kind of continue so that the slope is always in the negatives, meaning underneath the x-axis, prior to negative 1. After 1, is our slope positive or negative? Positive. So, and increasingly positive, yes, as it increases towards looking like a vertical line. So right after 1, you have a positive slope. It's in the positives, it's above the x-axis, but only maybe at a level of 1. As you get further and further away, and it happens pretty quickly, your slope by the time you get to 3, which would be about here, is a huge slope. So we just have a much higher number. Yes? Okay? So taking that point by point and really looking at a negative slope needing to be a graph below the x-axis. And any place you see a positive slope needs to be a derivative graph above the x-axis. Okay? Flip over to the back. We will do the second one because I did the first one in the first period today. Use the graph of the derivative. So the graph we are looking at is the graph of the derivative. Okay? We need to come up with the intervals on the original function, on the original f function, that it is increasing or decreasing. So similarly, I think I'm going to set up a graph with 1, 2, 3, 4. And looking at our derivative, given that this is above the x-axis, that means that the derivative is positive, yes? And having a positive derivative means the slope is positive. So on your original graph, I don't know what it looks like, but our slope is positive prior to negative 1. So there's negative 1. Our slope has to be positive in this interval, prior to negative 1. And then right at negative 1, your slope is at the level of 0, so it's going to be a 0 over here. And then right after negative 1, up until 0, your derivative is below the x-axis, meaning your derivative is in the negatives, meaning your slope is in the negatives, yes? And if your slope is in the negatives, that means you are decreasing. yes? From 0 to 1, you're back in the positive slopes. So from 0 to 1, your original graph must be increasing. And then after 1 and beyond, you're in the negatives. So if your derivative is in the negatives, that means your slope is decreasing. And you're not going to be able to figure out exactly what the function looks like. Because first of all, you don't know where it's placed, but you do know it's increasing up until -1, at which point the slope is 0, and it starts to decrease quickly until 0, at which point at 0, the slope is 0 again, and it begins to increase up until 1, at which point the slope starts to be negative again, and is negative the rest of the way. We follow? So when they say identify the intervals on which f is increasing, this is increasing from -infinity to -1, and again from 0 to 1. It is decreasing from -1 to 0, and again from 1 to infinity. Make sense? Okay. On this next question, again, we're not going to ever know exactly what the function looks like, but we are going to be able to come up with a somewhat of a sketch. So the derivative is positive from -infinity to -4. If the derivative is positive, what does that mean the original function is doing? Increasing. A positive derivative means that the original function is increasing from -infinity up until -4. And then from -4 to 6, the derivative is negative. And if the derivative is negative, what does that mean the original function is doing? Decreasing. And then from 6 to the rest of the way, our derivative or our slope is positive again, which means if your slope is positive, you are increasing. So I don't really know where this is placed or how steep this goes down, but that's the general idea. Yes? Okay. So then this is our function f of x. We were given the derivative of f, so we went back to the original function. So this section here, this fill in the blank, wants to know if we redefine a g of x function after some certain transformations. Now, what transformations happen to f of x here? What happened? What's the 3 multiplier out in front due to it? Okay, so it stretches everything, right? So it stretches it up and stretches it down. And also, what does the -3 do? Moves it down. So this whole thing, that's still not changing kind of where this is going, increasing and decreasing though, right? Everything has just been moved vertically. So there's no change. The derivative at -5, so the slope at -5 is still positive, yes? So it's still greater than 0. We're just filling in with a greater than or less than sign. The second function, g of x, they define as negative f of x, which does what to the f of x graph? Flips it upside down, so it's going to do something like this now, right? And so if it's flipped upside down, what is the derivative now at 0? Positive or negative? Positive. And then the last one does what to it? Moves it to the right 10 units, okay? So if I were to shift this to the right 10 units, where is this maximum now occurring? 6. I'm just going to change this. And where is this minimum now occurring? 16. So what is the derivative at 8? Which would be somewhere between 6 and 16. Negative. Slope is negative there, so it would be less than 0. Good? Okay, so your homework is there at the bottom. It's like, I didn't get to the bottom one in the first side here, maybe in the last period of the day. But, I'll show it. But this example in the top left is on the first, I'll post both videos because I did the different examples for you guys. And this example is on the other video if you want to see that. But the numbers for your homework are here. We do.